Hello again. Today we're talking about systems of linear equations. This is going to be lesson 2.2 in our second unit of study. So we're going to talk about different methods of solving systems of linear equations. And systems of linear equations is basically two linear equations that may or may not intersect, and our goal is to figure out where they do intersect, if they do intersect at all. So that's the point of solving a system of linear equations, figuring out the x and the y that is a solution to both equations that were given. So one way to do this is graphing. We're going to graph each line and see where they cross. Okay. There are pros and cons to each of these methods. The pro for graphing is that you really don't need any algebra to solve this. You just need to draw it. The con is if you have a solution that has decimals or fractions and you graph it, it's kind of hard to see where exactly your solution is. So you may want to use another method to get your answer to be more precise. So let's talk about an example. We have y equals 2x plus 1, and we have 5x plus 2y equals 20. And I've got a nice little graph here, and so I'm going to graph y equals 2x plus 1 first. And I'm going to use the fact that this is in slope-intercept form to graph this. So when it's in slope-intercept form, I'm going to find the y-intercept first. That's the 1. And then from there, I use the fact that the slope is 2 to find other points on the line. Okay, so there's my y-intercept of 1, and then to get any other points, I go up 2 and over 1, up 2 over 1 repeatedly until I can figure out where that line is. Now for line 2, that's not in slope-intercept form, that's in standard form. So what I do is I kind of hide my x's and solve for y. That's going to give me my y-intercept. And then I hide my y's and solve for x, and that's going to give me my x-intercept. So if I ignore the x's, then the equation is 2y equals 20, and that means my y-intercept is 10, and if I cover up my y's, the equation is 5x equals 20, which means my x-intercept is 4. So I know the line passes through the x-axis at 4. I know my line passes through the y-axis at 10. So using those 2 points, I can figure out where my line is. So there's the 2 lines, and now my job is figure out where those 2 lines cross. Well, I created a system where the solution is pretty easy to see. X is an integer, y is an integer, so there's the point of intersection right there. 2 and 5. And if I wanted to check that, I would plug in 2 for every x and 5 for every y, just to make sure that every equation was a true sentence. All right, then there is substitution. That's the second method. If you don't want to use graphing, or if you find you've got a decimal or fraction solution, then you might want to find it more precisely. You're going to use this method if you see one of your equations in y equals form or x equals something form. And you're going to start by substituting the expression that is equal to x or y into the other equation, and that will give you an equation that only has one variable, which you can solve for. And then you substitute that value into the other equation to get the value of the other variable. Okay? We're going to go over an example of this so it makes more sense. The pro of this is that you can find exact answers. The con is that there's lots of algebra. You really need to know how to substitute, how to use distributive property, and all that good stuff. So let's do an example. All right, the same one, I think. Yes, y equals 2x plus 1 and 5x plus 2y equals 20. So what I do is I see that y is equal to 2x plus 1. So in the second equation, the red one, I'm going to replace y with 2x plus 1 in parentheses. So now my equation reads like this: 5x plus 2 times what y was equal to, 2x plus 1, equals 20. Okay? And now, if you look at that equation, that only has x's in it. So I can solve an equation if it only has one variable. So if I expand the parentheses, I get 5x plus 4x plus 2 equals 20. Simplifying the left-hand side, because those 5x's and those 4x's can combine to give me 9x's, plus 2 equals 20. If I subtract 2 from both sides, I get 9x equals 18, and if I divide, I get x equals 2. So I know now that x equals 2, I just need to figure out y. So what do I do with that 2? That goes back up into my y equation that says that y equals 2x plus 1. So now I know that y equals 2 times 2 plus 1. And so y equals 5. The solution is 2 and 5. X equals 2, y equals 5. And again, I would check that to make sure I was right. The third is elimination. We're going to use this whenever both equations are in standard form. Something x plus something y equals a constant. So what I'm going to do is I'm going to multiply each equation by some constant so that either the x coefficients are the same or the y coefficients are the same, except for maybe the plus or minus. And then I'm going to add those equations together. And once one of the variables is found, I'm going to use elimination again to find the other variable. Okay, the pro for this one is that you still can find exact answers. The con is that it doesn't work for nonlinear equations. But we're only talking about linear equations today, so that doesn't really affect us too much. So here's an example. Okay, and I kind of rewrote the first equation so that it was in standard form. So I have 2x minus y equals -1, and 5x plus 2y equals 20. So I should expect to get the same answer this time as I've gotten on the last two examples. So what I did, I took the first equation, the blue one, and I multiplied every term by 2. So the 2x becomes 4x, the negative y becomes negative 2y, and the negative 1 becomes negative 2. Now if you notice, in the second line, that plus 2y, the red plus 2y, and in the third line, the minus 2y, those are opposites of each other. So now if I add the second line and the third line together, I get, yep, those cross out, and I get 9x equals 18. So if I divide by 9, x equals 2. All right, so now what I'm going to do is I'm going to take that first line again and multiply it by -5. That's going to make the 2x a negative 10x. It's going to make the negative y a positive 5y, and it's going to make the negative 1 a positive 5. And then I'm going to take that second line, if you can see through the yellow cross out, the second line, second from the very, very top, I'm going to multiply that by 2. So 5x becomes 10x, 2y becomes 4y, and 20 becomes 4y. Now, instead of the y's canceling out, the x's are going to cancel out when I add the two equations together. Negative 10x plus 10x is nothing, so I've got 5y plus 4y is 9y, and 5 plus 40 is 45. And if I divide by 9 on both sides, I get y equals 5. Same solution that I've obtained in the other two forms, so it looks good. But again, I would check to make sure that it's correct. Lastly, technology, which you need to be able to use, but you also need to understand what the technology is doing. So that's why I saved it for the last. So there are a lot of applications that you can use. There's a solver on the Casio that we use in class. And there's different ways of actually doing it in class where you can graph or you can use a matrix, or you can do all kinds of things to solve. So I won't go over any of those because there's just too many. The pro is that you just type in the system and you get the solution. I mean, you don't even have to think. Con is you don't know what the technology is doing, and so you don't really know the concept of why you're doing what you're doing and what the answer actually means. So those are the 4 methods that I'm going to present. There are more, but we don't really need to know them in our set curriculum. So if you have any questions, please let me know, and I will see you tomorrow.